Hello grade 12s. Today we'll look at the difference between relative frequency and theoretical probability. To demonstrate this, we'll use coins and dice. Let's look at relative frequency first. Relative frequency is defined as how often an outcome happened when an experiment was conducted. In other words, the relative frequency is the real number of times an outcome happened. Let's look at an example of this by tossing a coin. The coin was tossed 10 times. It landed on heads 4 times and tails 6 times. This means that the relative frequency of heads was 4 out of 10 or 0,4. The relative frequency was 6 out of 10 or 0,6. Theoretical probability is the prediction of what will happen when we carry out an experiment an infinite amount of times. Theoretical probability equals the number of desired outcomes divided by the total number of possible outcomes. Let's apply this to tossing a coin. There are 2 possible outcomes for tossing a coin, namely heads or tails. This means that the theoretical probability of tossing heads is equal to 1 out of 2 or 0,5. This means that when the coin was tossed 10 times, we should have tossed 5 heads and 5 tails. To summarize, relative frequency tells us what has happened, and theoretical probability tells us what we can expect to happen when everything is fair, unbiased, and random. Weather predictions are examples of experimental probability. We have all experienced days where the weather forecast did not include rain, and yet the day ended with a huge thunderstorm. These kinds of predictions are based on data collected over a long period of time, which means that the prediction is based on what has happened before. Let's move on to the difference between independent and dependent events. Independent events do not influence each other. An example of this is rolling a fair-sided dice. There are 6 equally likely possible outcomes for each roll of a dice: 1, 2, 3, 4, 5, or 6. If we calculate the theoretical probability of rolling a 1, it is 1 divided by 6. If we roll the dice again, the number of possible outcomes remains 6. Rolling a 1 does not make it disappear from the dice. This means that rolling a dice many times are independent events, as one roll has no influence on what will happen next. Dependent events are linked in such a way that what happens in the first event influences the probabilities for the next event. An example of this would be picking numbers for the lottery. In order to take part in the lottery, you have to pick 6 numbers from 1 to 49. No number may be repeated. The probability of picking the first number correctly is 1 out of 49. However, no number may be repeated, which means that the probability for picking the second number correctly is 1 divided by 48, as there are now only 48 options to choose from. The probability of picking the third number correctly is 1 over 47. The probability changes again as there are only 47 numbers to choose from. This pattern continues for all 6 numbers that are chosen. These events are dependent as the preceding events influence the number of options available to choose from. This changes the probability of a specific event happening. Dependent events are also found when we talk about the weather. The weather prediction for a specific day is influenced by the weather the day before. For example, heavy snowfall on one day will influence the temperature for days to come after the snow. The same can be said about sporting events. Playing consecutive games are dependent events, as players get injured or suspended. The morale and confidence of a team is also affected by winning and losing. The distance traveled to the match also has an impact, especially if it involves long trips. Very few things in real life are completely independent events. In some cases, calculations of probability do not predict real life. Once again, sporting events are a great example. You can look at how many times a team has won and lost playing another team, and you will still not be able to predict accurately what happens in the game. These predictions are more often based on personal preference than probability. Insurance companies use complicated probability calculations to determine the premium paid by the customer. For example, a man under 25 will pay 1,707 Rand 35 per month to insure a car, where a female under 25 will pay 1,053 Rand 36 per month for the same car. This is due to historical data. The data shows that men in the age group of 18 to 25 are involved in more accidents than women of the same age. Insurance companies charge more for the insurance because of this. But probabilities based on past events are not always accurate. Another example of this is the weather. We can calculate the probability of a specific temperature being reached on a specific day in a specific place by looking at the recorded temperature for 3 decades on the day and still be completely wrong. That brings us to the end of this lesson. Thank you for joining us, grade 12s. Remember to try the task video at the end of this series. You'll also be able to learn more about probability on our website www.mindset.co.za/learn. Goodbye.